Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syabinta Ahmad Safawi. So we are from Group 3. So today we are going to do presentation for our group project. Our title is Annual Resistance and Temperature of a Thermistor. This is my group member, which is me, Nur Syabinta Ahmad Safawi, Muhammad Fairuz, Muhammad Afiq, and lastly Nik Ahmad Amir Hakimi. Firstly, I will explain about the introduction. The authentic problem chosen by us through discussion among us is based on the unknown resistance and temperature of the thermistor, which is categorized in an electrical engineering problem. So what we want to solve in this project? Firstly, this project is aiming to determine whether the thermistor is calibrated properly or not. Second, we need to solve a non-linear equation first in order to determine calibration of the thermistor. So we used two methods from three methods that we have learned in chapter 1, which is second method and Newton-Raphson method. So we want to compare and confirm that the resistance data obtained compare well with the published data for the range of which thermistor will be used.
Assalamualaikum and hello. My name is Muhammad Fairuz bin Muhammad Noor. In this part, I will explain about a method for our projects. So at the method, we use two solution. The first solution is we use a second method, and the second is Newton-Raphson method. And now we go to the manual calculation. We can see first manual calculation, we use a second method. This is a value for FR, this the question given. Ln R for resistance, and this is a F1100, and we get the value. And this is for F1400, and we get this value. And after that, the question FR less than E equal to negative 5.5698 multiplied by 10 power of negative 9. After we get this value and what the question we need to do the solution. And for table we must create a second method table or construct the formula for find the R, x1 equal to here, and at here we just put the value and we get the answer for x. After we get answer for the x, and we put s equal to r, and we get the value of r, we just put at here again, and we get for the fr, and we get for the last at here, and we stop. This for table second method, and we find the iteration 1 and iteration 2 and iteration 3 and iteration 4. This is absolute for iteration 1, 2, 3 and 4. And after that, we go to the manual calculation for Newton-Raphson method. And for Newton-Raphson method, also same, this is question 1, and but FR, and we must find for differentiate of FR. So it means we must construct the same table, but we add the F differentiate R. So for find X for Newton-Raphson method, this is a formula, and we just put the value again, and we get the value of R. And after that, we put the value at R, and we get for the FR. And after that, we put the value of R, and we can get the F differentiate of R. And after that, we find the absolute for iteration 1, 2. This is the value.
Assalamualaikum and hi, my name is Muhammad Afiq bin Batrul Hisam. My matrix number is DA200125. Okay, today I would like to talk about the simulation that we use is Microsoft Excel. For this is the first solution, which is for second method. The function that is stated here 2.341077 times with 10 power of negative 4 times with ln R plus 8.775468 times 10 power of negative 8 times ln R power of 3 minus 2.293775 times 10 power of negative 3. So this is the formula to find value R, which is R1 times with function R2 minus R2 times with function R1 divided by function R2 minus function R1. So this is the first value for R, which is 11,000. So how do we find FR value is 2.34177 times 8 power of negative 4 times with ln, we insert the value R 11,000 right here, plus 8.775468 times of 10 power of negative 8 times ln, again we put R power of 3 minus with 2.293775 power of 10 power of negative 3. Okay, next, this is the second value for R. So this is the same, we just put the value R in the equation FR value. So as you can see, 14,000 at B7. So we replace R with B7. Okay, next I will show about how to get the value R is B6, which is R1 times with function R2 C7 minus with R2 times with function R1 and divided by function R2 minus R1. So we get the value R. So this is also the same. We just insert the new value R in the FR equation. Okay, next is the second solution, which is Newton-Raphson method. So this is the function FR value, same as the first method. So this is the differentiate function R. We get 2.341077 times 10 power of negative 4 plus 2.632640 times 10 power of negative 7 times ln R power of 2 divided by R. So this is the formula to find value R, which is Ri plus 1 equals to Ri function Ri divided by function inverse Ri. Okay, the first value that stated in the equation is value R, which is 14,000. So we just insert the value R in the equation FR. So which is we get 0.002341077 times ln. We insert the value R 14,000 plus 8.775468 times 10 power of negative 8 times ln 14,000 power of 3 minus 2.293775 times 10 power of negative 3. So we get value here. Okay, for F inverse R, also insert with the same equation. We just replace value R in the equation. So we get 2.341077 times 10 power of negative 4 plus 2.632640 times 10 power of negative 7 times ln, insert value R 14,000 power of 2 divided by R 14,000. So we get the value here. And next, how to find the second R is using this formula Ri plus 1. So Ri minus function Ri divided by function inverse Ri. So here is 14,000 minus Fr divided by function inverse R. So we get the value for new R. Okay, next. How do we want to find the value for Fr is we just replace the new value R into the function, this function. Then for the function F inverse R, we also replace the new value R in the F inverse R equation. So we just have to repeat the step using this formula and this function. Okay, I think that's all from me. Thank you.
Hi, my name is Ni'ama Melkimi, Binergy Kepli AE200008. So for result analysis, we choose Microsoft Excel as program to prove our manual calculation. So Microsoft Excel is one of the mathematics program that is very easy to use, very easy to explore, visualize, and solve mathematical problem. So for second method, as I equal to 4, we got the value for R equal to 13,078.41509 and FR equal to negative 6.50054 exponent negative 9. So for Newton-Raphson method, for I equal to 4, we get the value for R equal to 13,078.40827, FR equal to 0, and F prime R equal to 1.97089 exponent negative 8. So in conclusion, the goal of this group project is to measure the temperature change on a thermistor and calculate resistance. A thermistor is a form of resistor that is very sensitive to the temperature, also known as temperature sensitive. So the second and the Newton-Raphson method can produce solutions that are very sufficiently near to the data obtained by bisection approach. So we choose to apply additional methods. So based on this project, we learned how to inspect the resistor R used to gauge the thermistor temperature. That's all from our group. Thank you.